This question is from GATE Mechanical Engineering of 2012. This is question number 12. The question is, consider a function f of x is equal to modulus of x in the interval x greater than equal to -1 and lesser than equal to 1. Now at the point x is equal to 0, f of x is, so four options are given to us. First, let's see the given function. It is f of x is equal to modulus of x. Okay. Now to check the continuity, of this function, we know that left hand limit should be equal to the right hand limit. Okay. Now left hand limit, let's write this function first. F of x is equal to modulus of x, which is equal to positive x when x is greater than equal to 0 and negative x when x is lesser than 0. Okay. Now let's find the left hand limit for this. Left hand limit, so we can write this as limit x tends to, at 0 we need to find that x is equal to 0, and this should be equal to the function at the given point. So at 0 we need to find, so this will be 0 minus f of x. So this we can write as limit x tends to 0. When x is lesser than 0, the value of function is negative x. So this will be equal to 0. Okay, and let's check the right hand limit. So limit x tends to positive side of 0, so f of x, this will be equal to limit x tends to 0, and this is when x is greater than 0, it is x, so this is again 0. Also at f of 0, the value of function is 0. That means this function is continuous. Okay. Now let's check whether it is differentiable or not at x is equal to 0. At x is equal to 0, let's check the differentiability. Of this function of f of x. A function is differentiable when its differentiation is continuous. That means when the left hand derivative is equal to the right hand derivative. Okay, let's see that now. So left hand derivative for this function, so in general we can write it as limit h tends to 0, it's a dummy variable, f of x plus h minus f of x upon h. Okay, and here f of x is modulus of x, that we already know. So this will be equal to, and this is left hand derivative, so this will be 0 minus. Okay, so this is limit h tends to 0 minus. Now we'll just substitute the value of function, so this is negative x plus h minus negative x, because when x is lesser than 0, the value of function is negative x. Okay, that's why we are substituting, we are putting a minus here as well as here, and here it will be h. Okay, so we can write this as limit h tends to 0 minus, or simply we can write 0, and this will be negative x minus h plus x upon h, which is equal to limit h tends to 0 negative h upon h, which is equal to negative 1. Okay, so the left hand derivative here, because h upon h will be 1, so this will be negative 1. Now let's check the right hand derivative. Okay, so right hand derivative we can write as limit h tends to 0 plus, because it is in the right hand side, the derivative plus h minus f of x upon h. So this will be equal to limit h tends to 0 plus, and this will be x plus h minus x upon h, and we'll see that the value of this limit h tends to 0, this we are getting h upon h, which will be equal to 1. Now we see here that the left hand derivative is -1 and the right hand derivative is 1. So we see here that left hand derivative is not equal to the right hand derivative. Okay, so they don't agree with each other. That's why we say that the derivative is not continuous. That means the function is continuous. Okay, I know it is a little confusing, but we can say that the function is continuous but not differentiable. Okay, so the function is continuous but not differentiable. We can also check this from the graph of this function. So we are given, let's say this is x and this is y axis. Now we are given the function y is equal to f of x is equal to modulus of x. Let's plot it. So this will be something like this. So when x is greater than 0, right, so the value of y is x, and when x is lesser than 0, the value of y is negative x. Okay, so y is negative x. Now we see here at x is equal to 0, the function is continuous, right? There is no break in the function, but we are getting a sharp point here, and that's why this is not differentiable. Okay, the differentiation is not continuous. The function is continuous, but the differentiation of the function is not continuous. Okay, so let's go back and match with the given options. So the function is continuous and non-differentiable. So option C is the correct choice. For more on this topic, you can refer to NPTEL course, lecture number 5, limits and continuity. You can also follow the consecutive lectures in which the differentiability is discussed on basic calculus for engineers, scientists and economists by Professor Joydeep Datta of IIT Kanpur.